Hi, I'm LT, and I recently did a video about the Amax toothpick motors, 7500 kV, and I was prop testing to see what props made the most thrust and what was the amp draw. And I did it all on 2S since that's what the motor was rated for, and I used a very large 2S battery. I'll put the link below to that video. And in this video, what I wanted to do is have a look at a few different batteries, ones that you'd actually fly with rather than the really big battery I used for that earlier prop test. Because I used a big battery earlier because I didn't want any voltage sag in those tests, just to see really what those props could do with an uber infinite battery, as it were. But this time I wanted to see what batteries should I really be using with these motors, and just see the effects of different batteries running this motor at full chat with the recommended King Kong biblade. So in the previous video I kind of explained the setup you're currently looking at, so have a look at that again. And labelled it all up. I think it's pretty much self-explanatory. So in this video I won't go over that, and rather I'll just talk you through the results I got by testing the classic Amax motor with the classic King Kong prop.
So these are the batteries we've got on test. We've got a pair of 1S Whoop batteries, 250 milliamp hours, 30 to 60 C. These are put together with a rather dodgy looking homemade series connector, 20 AWG wire and XC30. Also tested just the once, not twice, like most of these batteries. I have a aging pair of 300 milliamp hour Crazy Ponies. These didn't do very well. That's why I only tested them once. Then the tests continued with this one. This is a Nano-tech 260 milliamp hour 35 to 70 C. It's a little bit heavier than these. These cost around £15 for 5 or 6, I can't remember what it was. These were an absolute bargain. These came from Hobby King. And actually, here's another one. They were £4 for 5 of them, 2S 260s. However, they did not come with the right connectors. So they came with this connector, which on first glance it looks like a balance connector, but it's not. And there's no main power connectors, so totally the wrong connector, so you have to go and buy your own balance connectors, and obviously XC30s as well, and spend the time to put them on. But at the price, I thought, well, let's just have some extra batteries. They're so cheap, even if I don't end up using them for flying quads. Good old GMB, heavier 450 2-cell 80 160C, pretty stock battery. This one was a little bit cheaper than most because again it had a weird connector on it, but it's the same as the ones that come with the XT30s. Balance lead on this one was kosher, so just a case of whacking on an XT30. Then what did I do here? So this monstrous looking thing, again, I put the balance lead on it and the XT30 on it, and it's actually one of these, but this time 3S. So it's one of these plus my other bargain bin battery, where 5 of these for £4 as well, and they are actually the same cell as the 2S ones, except for these ones have another weird connector on them, and they're 1S. What's kind of nice about this connector is you can shave off the tabs on the sides and that will actually fit a PH2 whoop connector, but you have to make sure you get the positive and the negative the right way around, because you could put it on either way. Anyway, yeah, that's all very nice. I'm calling this the Franken Nano Hack battery. A proper Hobby King Nano-tech battery, 460 milliamp hour. Came with all the right connectors, fantastic, a little bit more expensive. This actually came out only fractions behind the GMB, actually, so I do rate this Nano-tech because it is cheaper than the GMB, even the GMB with the wrong connector, which is cheaper than the one with the right connector. Everybody loves X230, it seems, and then you pay for it. And then this is really one of the stars of the show. So this is a GMB 80 160C 300 milliamp hours. So this is a pretty new to the market battery. High volt option, not that I like to charge to high volts. Generally reduces the number of cycles you get quite dramatically, it seems. Shutterbug also reviewed this. I'll link to his thing on YouTube. He does an excellent battery review. Lastly, obviously this is not a battery for a toothpick. It's way overkill. It's 700 milliamp hour 3S battery that I use for testing. I wanted to see what a large capacity battery on 3S could do compared to this Franken Nano Hack battery, and we'll look at the results shortly. I only tested this the once because it clearly isn't a viable option for actually flying. Other batteries I do have really briefly but not included in this test and will probably feature in future testing is the 3S version of the 2S one here. Potentially might use it on the Sailfly when that comes around. I have also the Sailfly's battery here, Happy Models 300 milliamp hour 3S 3060C. Didn't actually have that at the time I conducted the test, hence I didn't try it. And also I have a 450 3S tattoo here, which at some point I might get around to trying with the Sailfly motors. So that's it. That's my little collection of batteries in approximately the order they appear in the test. And let's have a look at the results.
So here are the results. In the top half of the screen, there's one set of results. That's my first run. And I probably made a few mistakes there and reset the test in many cases of those batteries. And therefore I'm putting less stock in those results. But the second half of the screen shows my second run, fully charged battery, right off the bat first time, so probably pay a little bit more attention to those results, and it probably explains why the values are a little bit higher for each one of the batteries. First core finding is a 3S, good 3S battery was capable to produce over 200 grams of thrust with this prop motor combo, but it did so at 87 degrees C, and it actually was consuming more than 100 watts, just over, at least for the first 3 seconds or so, and the motor's only rated at 100 watts, 12.5 amps times 8 volts, 100 watts. Now, I had it on good authority that it's okay to overvolt motors, so run this on 3S, provided you stick to producing less heat than the spec sheet, and we don't have a spec for that, unfortunately. I have asked Amax. They haven't sent any data on that. but also it's anyway over the power rating, so not advised. It really will shorten the lifetime. With the lesser 3S battery, certainly on the second set of tests where there's a full set of results, and there was a bit of a mess up in the first run for that one, we can see that I don't draw over 100 watts of energy at that point in time. So that's probably a feasible overvolt in that case. So looking further down at the second half, the rest of the core results, I tested two 1S Whoop batteries in series, GMB 250s, non-high volts. They had a combined weight, including the series adapter, of 15 grams, so that's 25% lighter than any other batteries here, and they'd therefore had the highest sort of thrust to weight ratio, and I'm just taking into account the weight of the battery here versus the amount of thrust it generated, or at least the prop mode combo generated. And having flown this combination, I really like it. I mean, you can definitely feel that lighter battery in the air, still get 5-minute flight times, and it's just solid performer. So that is a good recommended option. That is one of my preferred. And the other really good performer is the 2S GMB 300 milliamp hour 80/160C battery, and Shutterbug did some battery testing. He tested this battery and it came out in the top spot. I'll put a link to his more extensive and really great testing below where he reviews that one. I can feel the extra weight in the air, but it is faster, I think. Certainly my results here show it produces 10% more thrust, slightly longer flight times as well. So yeah, really good. And that was all done at non-HV, and that is an HV capable battery, so I guess if I high volted it, it would be a real screamer. But yeah, want more than 20 cycles out of that, so not going to high volt it. And then the 3S kind of lesser Frankenstein Nano-tech hack battery that I put together, that produced 188 grams of thrust. Yeah, I haven't actually tried flying it. I figure that maybe it would fly well, but certainly I don't believe the Crazy Bee is up to delivering the amps. As you can see, it consistently over 10 seconds was drawing over 7 amps, so higher than the burst rating of the Crazy Bee. Really feel uncomfortable trying that, but will be putting the get board in the toothpick to give that a go. Lastly, I calculated the internal resistance based on the voltage drop and the current draw, and I also discharged these cells after I finished using them, let them cool down, and put them on the ISDT charger I have, which tells you the internal resistance as well. And when you measure internal resistance, the temperature plays a huge part. And of course, the calculated internal resistance, that was while the battery was hot and charged and straight off the or on load, and the ISDT charge measure was clearly a cold battery, just as it went on to charge, so from a discharge state. So quite a variance there, but quite a consistent variance, and it's probably quite reflective of the C ratings of the batteries. So that was just a bit of an aside that I thought I would measure and throw in. So that's it for this round, and I think where this whole test can be improved is to strap the whole quad to the thrust rig and repeat these tests for at least the second half of the screen with the whole quad on it, because obviously I'm just drawing one motor's worth of energy off the battery in this test and not four. So it'd be interesting to see how it changes. I can certainly say that the two 1S batteries in flight, just going for the ultra lightweight thing, I really like that. I have to say. So will that be actually the best? Reserve judgments, and I'll try the 3S anyway. All right, thank you very much. Bye.